Yeah, warm good morning class. Uh, in the previous video, we have seen what is tool steel, why tool steel, what it is, what are the chemical, what is the major chemical compositions, and what are the types. Okay, so in this video, we are going to see the types of tool steel in a in a briefer way. Okay, the first one is shock resistance tool steel, as the name implies that here the particular tool steel is made so that here the toughness and the hardness of hardness, these two, toughness and the hardness, these two properties are the major, has the prime importance for this shock resistance tool steel. Means that here the first one, it is that the carbon content. So as I already said, if you are increasing an alloy in a chemical composition of a steel, you can see hardness increases. So as like way, if you are increasing carbon content, here carbon content is from 0.5 to 0.6 percent, so that the carbon will get increased. So the hardness get increased. Here the alloying element it is used is chromium, tungsten, molybdenum. Here this chromium, tungsten, molybdenum as a characteristics of improving the hardness, toughness. So and you can see the hardenability increases. So these shock resistant tool steels are generally water or oil hardened, so that here the other thing is that it is low temperature tempering is carried out in this particular type of shock tool steel, where as I already said, toughness and the hardness are the prime important. Okay, so here other than that, you can see the silicon, manganese steel are included in this group, as its name implies, silicon and manganese. So the silicon is 2% and manganese is 1% is added towards this steel, so that here due to this high silicon content, so here decarbonization and grain coarsening happens. So you can see this due to this so the silicon content will form silicon carbide when taking this carbon into the carbon with itself. So it forms, so there will be decarbonization happens inside the grains and grain coarsening happens. So the silicon carbide will in turn improve the strength of a particular shock resistance tool steel, right? So here it is majorly used in chisels, pneumatic chisels particularly, punches, shear blades, scaring tools, and river sets and driver bits. Right? So the next one is hot torqued tool steel. Here the carbon content is actually from 0.3 to 0.5%, right? And moreover, these steels are used in the high temperature metal forming operations, where the temperatures are around 200 to 800 degrees Celsius. Here, as the name implies, it is used in a high temperature. This particular steel should have a high retardness, wear resistance, toughness, and erosion resistance, because it is because this particular steel is used in the high temperature, right? So as well as it should have a good thermal conductivity as well, so that it can dissipate more heat outside, so the tool depletion will get reduced. Okay, there are three groups depending on three groups in this hard work. First one is chromium based, tungsten based, and molybdenum based. So here it's a number variation, it is H11 to H90, means this is the groups which is so the this tool steels are identified based on this group numbers, right? So the first one is chromium based. Here chromium is around 3.25% and a small amount of vanadium, tungsten, molybdenum base is used. So these addition of these chemicals or these elements will have a characterization of increases in high redness and high hardenability. So here due to this, the oil quenching is made in order to is done, so that here the dimension stability will be retained. So the and also the tempering is done. Okay, so that tempering is done with a temperature above 550 to 675 degrees Celsius. So here the applications are on hot dies for extrusion, forging, mandrels and punches, and over high stress structural parts for supersonic aircrafts and hot torque steel. So here this addition of, as I already said, oil quenching is done, but here the dimension stability is not at that part important, but the oil quenching is done in order to make the material so hot so that can be used in the supersonic aircrafts and the hot worked steel. Okay.